A warm welcome to this session on Carryout visual inspection of photovoltaic modules. At the end of this session, you will be able to perform visual inspection photovoltaic modules before installation and in installed plant.
Information of different manufacturers or international standards. The International Electrotechnical Commission (IEC) has established quality standard certifications that are widely recognized throughout the solar industry and has gained acceptance in the past 15 years. IEC 61215. The IEC 61215 certifications is for crystalline photovoltaic modules. It covers the parameters which are responsible for the aging of photovoltaic modules. This includes forces of nature like sunlight including ultraviolet (UV), climate, changing of climate, coldness, warmth, humidity, mechanical load, hail, wind suction, wind pressure, snow. IEC 61646. The IEC 61646 certification is for thin film photovoltaic modules. It is in many aspects identical to the international standards IEC 61215 for crystalline modules. Additional tests take into consideration the degradation behavior of amorphous silicon due to the temperature and the irradiance exposure. Passing qualification tests means the product has met a specific set of requirements. Knowledge of possible failures. Failure classification. For clarity purpose, it is important to be clear about what is considered a failure. Like any physical product, solar module issues could be classified in 3 categories. 1. Infant failure. Up to 2 years after delivery. Infant mortality failures occur in the beginning of the working life of photovoltaic module. From experience gathered, failures observed are junction box failure, glass breakage, defective cell interconnect, loose frame, and delamination. Number 2. Midlife failure up to 11 to 12 years of operation. An average of 2% of the photovoltaic modules is predicted to fail after approximately 11 to 12 years of operation. Examples of issues include junction box and cables failures, burn marks on cells, and encapsulant failures. Number 3. Wear out failure from 13 years of operation. Wear out failures occur at the end of the working lifetime of photovoltaic modules. Failures encountered here are delamination, cell part isolation due to cell cracks, and discoloring of the laminate. Prepare a visual inspection checklist for the evaluation of mounted photovoltaic modules. Photovoltaic system performance is generally dependent on incident irradiance in the plane of the solar panels, the temperature of the solar cells, the spectrum of the incident light. Furthermore, it is dependent upon the inverter, which typically sets the operating voltage of the system. In the table given below, let us study the visual inspection for the evaluation of mounted photovoltaic modules. Failure or degradation of EVA encapsulant delamination. Possible causes are humidity plus moisture, UV sensitivity of adhesives, defective adhesion during manufacturing, external agents contamination. Effects could be moisture ingress, corrosion, transmittance losses, power losses, abnormal temperature distributions. Failure or degradation of hot spots. Possible causes are different thermal expansion coefficients between cell components, shading, soiling, defective cells, cracks, fractures, low shunt resistance, faulty bypass diode. Effects could be burns, lower total current, damages on EVA or glass, encapsulant discoloration, power loss, thermal stress among cells. Failure or degradation of soiling, glass discoloration, weathering. Possible causes are poor tilting of modules, defective cleaning protocols, long-term exposure in dusty environments. Effects could be transient or permanent transmittance losses, power losses, cosmetic changes, permanent allocation of particles over the modules, failure or degradation, faulty soldering, fractured cell. Possible causes are defective fabrication, transport and or handling, long-term thermal stress. Effects could be loss of generation or evacuation of charge carriers, uneven temperature distribution, increased series resistance. Define inspection checklists and prepare forms for filed inspections. Analyze the collected data, divide into various sections and document each section by the appearance or properties. Site information. Inspection at the back side of the module. Module data. Rear side glass. Back sheet polymer. Wires. Connectors. Junction box. Frame grounding. Define inspection checklists and prepare forms for filed inspections. Analyze the collected data, divide into various sections and document each section by the appearance or properties. Inspection at the front side of the module. Frame, frameless edge seal, glass or polymer, front, encapsulant front, metallization, silicon cell. Prepare a visual inspection checklist for the evaluation of mounted photovoltaic modules. Facilitate the user by easy questionnaire and answerable checkboxes like the one given below for the inspection of mounted photovoltaic module. The main components for evaluation are 1. Label, 2. Backsheet, 3. Junction box, 4. Wiring, 5. Frame, 6. Front glass, 7. Encapsulation, 8. Cells, 9. Cell metallization, 10. Cell interconnection. Component, label, possible defect, missing, poorly attached, information is missing, incorrect spelling. Component, backsheet, possible defect, delamination. Component, junction box, possible defect, faulty electrical connection, cracks or breaks or gaps in housing, sealant failure, electrical polarity not indicated. Component, wiring, possible defect, wire or wires missing or poorly attached, too short and or too thin. Component, frame, possible defect, damaged, adhesive or sealant failure. Component, front glass, possible defect, cracking, scratches. Component, encapsulation, possible defect, delamination. Component, cells, possible defect, fake, dummy pieces disguising missing material, cracks, partially covered, scratches, differently sized, edge chips, all cells very shiny. Component, cell metallization, possible defects, fingers not connected to bus bar, not the same pattern on all cells, fingers off edge of corner of cells. Component, cell interconnection, possible defect, interconnection is discontinuous, cells connected in parallel or counterfeit, poorly aligned and or soldered. Cells connected in parallel or real cells. Defects are present suggesting module is used rather than new. Summary: indicate if any defects and safety issues are present, and some score.
Recap. In this session, we have learned how to perform visual inspection photovoltaic modules before installation and in installed plant. Hope you have understood all the concepts in this session. See you in the next session with a new concept. Thank you.